Welcome to Open Source Spotlight. We invite open source authors and ask them to show the tools they're working on. Today we have Matt. Hi Matt, tell us a few words about yourself and about the tool you want to show us.
Hi there, thanks for having me. So my name is Matt. I work for a Canadian startup called Polyseam. We're building an open source tool called CNDI, which enables you to deploy open source applications like Airflow and Redis just as easily as you could buy a platform as a service equivalent. Tool provides you with a number of templates out of the box. Templates include Airflow, Postgres, Hop, MongoDB, Neo4j. You select where you want to deploy, and we help you deploy that application to your infrastructure. So with that, I guess we'll jump right into the CLI and give the tool a spin. Call CNDI init to initialize a new project. Oops, we're going to first create a GitHub repo.
And GH, I guess, is a command line tool from GitHub, right?
Exactly. Yeah, this is just the GitHub CLI, and we're going to say we want a private repo, and we're going to clone it right after we create it.
Oh, that's convenient. I have never used it.
Yeah, it is. Oh, I just forgot to say create. Yeah, really convenient. You can open pull requests all from the terminal. Very nice. And we're going to use it a bit later for a subsequent step as well. So now that we have our repo, we can call the initialize command, and it's going to ask us what we want to name our project. It's guessing that it's the name of the folder. And we're going to deploy today Airflow on EC2, but you can see that we have many apps to choose from, and not just EC2. You could choose EKS or Google Compute Engine or Azure and AKS. These are all options. We're going to go with Airflow on EC2, and we're going to use our GitHub username and token instead of SSH this time. And now it's asking for the URL of the repo we just created. And this is going to be the repo that holds all of the cluster manifests as well as the infrastructure as code that generates this cluster. And because we're deploying to EC2, it's now asking for AWS access key and secret. And so each template is going to present a different set of questions depending on where you're deploying and what application you're deploying. And I happen to have a private repo that contains my Airflow DAGs. If you've never worked with Airflow before, they're just kind of Python files that can be orchestrated. We're going to give Airflow access to my set of DAGs here and pass in my Git credentials to access that repo as well. Now we're going to tell CNDI that we're going to deploy ArgoCD, which is our Kubernetes GitOps tool. We want that to be accessible on this domain name, and we're going to follow the same pattern and make Airflow accessible on its domain name. And now, in order to provision TLS certificates, Let's Encrypt is asking for my email address.
Okay, so it's more comprehensive than I initially thought it would be, because it's asking a lot of stuff.
Yes, and this is kind of the kitchen sink where a lot of these things we can take as defaults, and for these database credentials, all that stuff can be taken as defaults. But yeah, we aim to provide kind of like the best out of the box experience that we can for each template that we've built.
It's amazing.
Thank you. So with that, it spit out a README that talks about not just how to use Airflow, but specifically how to use it on EC2. And a number of configuration files. This is the most important one. It talks about the infrastructure layer, which is kind of what VMs on EC2 are we going to run this cluster. There's a section then for Kubernetes manifest. This is a pile of Kubernetes YAML. And down at the bottom, we're provisioning two Helm charts. One is cloud native Postgres, which is what Airflow is going to use for its metadata store. And then we're provisioning Airflow as well. And it's going to have access to my DAG repo using the credentials that we passed in. .env file. I'm going to expose my credentials here for a second, but we'll make sure we change those before we upload the video. But yeah, we
I
provisioned
guess
a
this
password
is
for.
something you do not put to Git. You do not push to Git, right?
Exactly. Yeah, this .env file has already been Git ignored, so it's not going to go up in the source code. It has credentials for the clouds. It has credentials for the database. And those
You'll
aren't.
need to change a lot of things after this demo, I guess.
yeah, at least 3.
At least 3, yeah.
And with these credentials, we're able to now, especially with the git sync variables here, we want to get them into Kubernetes, but we want to do that without putting them in the source code. And there's kind of a struggle with GitOps. Everything should be managed in Git, but yet your credentials aren't supposed to be in Git. And so the first step to solve that problem is we're going to go back to the GitHub CLI again. And they have a nice command called GitHub secret set. And that takes in a path to an environment file like we have. We run that and run it again because sometimes GitHub fails, but we've now set all of these environment variables in the GitHub Actions runtime. And with that, all we need to do now, we can see that CNDI provisioned some secrets. These secrets are actually encrypted, but they have the credentials that Kubernetes needs to access things like Git for our DAGs. And so we'll do a git add dot and a git status. We can see CNDI created a lot of files for us. Terraform infrastructure as code, Kubernetes manifests, the README that we already showed.
So I guess we need to have Terraform binaries too, or
we're going to take care of. We're going to take care of that for you in GitHub Actions.
Okay.
Yeah.
Okay. So I guess the Actions M environment already has the Terraform binaries, right?
Right. Yeah. So we, in addition to provisioning the environment variable and the config file that I showed, we also added this Kubernetes, or sorry, GitHub workflow, which is going to install the Terraform CLI. It's going to install the CNDI CLI, and all of those secrets that we didn't want to upload as source code, they're going to be passed in from the GitHub secrets backend. And that's how we can get these credentials that we never uploaded to Git. We had to upload them through kind of the CLI with that secret set command I just showed. Now, if we make our commit and push this up, we can kind of watch how that comes together.
Yeah, amazing.
So any second now, we're going to have the GitHub Actions VM spin up. There we go. So there, in the GitHub Actions runtime, we can see that it pulled down the Terraform CLI. And now it is being used to provision all this infrastructure. And this is kind of the slow spot because now we're just waiting on AWS to resolve these resources. Should be.
Because it is creating an EKS cluster, right?
In this case, it's an EC2 cluster.
EC2 cluster. But where does, because you mentioned Kubernetes.
Yeah, so we're installing a Kubernetes distribution on top of EC2. So we could have selected the EKS option. If I go back to the CLI again, we'll say we're going to overwrite, but we'll cancel before we do any damage. We do have options for EKS.
EC2. Okay.
As well as EC2.
So in this case, EKS would be like actually using AWS, right?
Right. And EC2 is also using AWS, but instead of their managed Kubernetes offering, we're installing MicroK8s, which is another Kubernetes distribution. We're installing that directly on the VM. And that should be suitable for most users, and you'll actually probably save some money not opting for the managed Kubernetes that AWS
so you
provides.
have to pay like, I don't know, a few dollars every day, right? Just for this existence, for the mere existence of your EKS cluster, even if there are no nodes, you just need to pay for this, right?
Exactly, yeah. And when it comes to deploying CNDI clusters on EC2, you're really only paying for the compute you use, so much better deal. Sometimes you need the managed control plane, but if you don't, this is a good option. We're still able to provide a highly available distributed cluster on EC2, and that should be good for many use cases.
It's creating a load balancer right now, right?
Yes, it is, yeah. And that load balancer is going to spread traffic across our 3 EC2 instances, and we should actually see those coming alive over here now.
Cool.
They're just, they're just spinning up. The last thing that this is going to spit out for us is the domain name of that load balancer. And we can actually probably jump ahead to that spot because I know where to look. There we go. So this is the domain name of the load balancer that's almost ready. And take that to root 53. And so this is my domain registrar here. I'm going to create a CNAME record.
And this is something you would do manually anyways, right? So this is not something CNDI does, or is it?
Right. So it does it. There we go. The tool just exited, and what it did for us was spit out the domain name we need as an output, just for convenience, as well as the resource group where we can look at all of the other resources that CNDI created. One of them being the load balancer, but also the nodes and the VPC and so on. So yeah, we would have to do this by hand anyway. We'd copy this URL, and we paste that into root 53. It's the same one again. Oh, that was I took the resource group URL, but
it shouldn't be resource group URL, right? It should be the URL to the load balancer.
Exactly. Yeah, just a misclick there. This one here, public host, is the one I meant to grab. And the subdomain that I passed into the tool, if we go back, we can see that I did airflow.cndi.link and argocd.cndi.link. And in this case, they're both going to go to the same load balancer because Kubernetes Ingress is going to handle directing that traffic further. So 2 CNAME records, both pointing to the load balancer we created. And
so the thing that we did in the configuration was more like, okay, here the traffic will come, and then we need to configure this, create this CNAME records ourselves, right? The tool is not going to do this. Okay.
Right. And we have a feature we've internally called auto DNS, where we do have the credentials to talk to the cloud already. So if the user has their domain name in AWS, we'll be able to persist these records automatically, but we don't do that yet. For now, that step is manual like we're doing it now. So now we have those 2 domain names, both pointing to the load balancer. And from there, we can go into the EC2 dashboard. If we wanted just for something to look at while things continue to spin up here.
So right now we're logging into the EC2 instance with Airflow, right?
Right, yeah, one of the 3 instances we provisioned. And so we can do sudo microcates kubectl get nodes. And again, microcates is the distribution of Kubernetes that we installed on top of the VM. And that's why we can call it to it here. We can see that it has
these are
3
the 3
nodes.
Yeah.
And we can also now say we want all of the records and the ingresses in the ArgoCD namespace. There aren't any yet. So Kubernetes has spun up. It's aware of the nodes. And now it's starting to resolve all of our resources in that. It's also just going to take a minute. There we go. Now we can see that we have some ArgoCD containers being created. And ArgoCD's job is to take the files from the CNDI cluster manifest directory and apply them to the cluster. So Argo is working with a pull model. It's polling something like every 100 seconds to look at this cluster manifest folder and ensure that all of these YAML are the state of the cluster. And so
Can
if
we
we
manually touch these YAML files? Like once we did the init, and if I know Kubernetes or Helm or whatever it
yeah,
is, I can
you definitely
just
can.
go ahead and okay.
However, even though you can do that, we would recommend instead that you take the files that you would edit and you edit them in the CNDI config file instead.
Mm-hmm. So then they're in sync, right? So then
Right.
CNDI manages it goes and updates these files.
So the way it works is if you edit this CNDI config file, let's say we're going to add a node. So we want to take this three node cluster and make it a 4-node cluster. We would edit this file. And then if we wanted to also take the number of Postgres database instances to 4 instead, the next step would be to call CNDI OW or CNDI overwrite. And if we look at our Git history now, we can see that not only did we change that one file, but we've also overwritten a bunch of these other files here. And so the CNDI config YAML is kind of simplifying the interface for the user so they don't have to muck around in all of the kind of Terraform resources and manifests that maybe they don't have much familiarity with. You can see this stuff is still going. We do know the domain names ahead of time because we set them ourselves. Not quite ready
Still in
yet.
progress.
Mm-hmm.
Okay. What is it doing right now? Do you know?
Yeah, ArgoCD is spinning up these pods and going to look at the manifests in the repo.
So we have the nodes, but pods are not created yet. Deployment is not created yet, so it's creating them, right?
Yeah, so the nodes are there. Kubernetes is running, and these are a bunch of pods running within Kubernetes and services running within Kubernetes. What hasn't quite finished is applying all the manifests that are in our Git repo, including the ingress. So like one of the resources, and we can go look at that, is cluster manifests and Argo ingress. And it has a reference to the domain name where this thing will exist. And it's also asking for a TLS certificate from Let's Encrypt. So not only is this thing going to spin up with its own domain name over the web, it's also going to be served with TLS. And so that will be one of the other things we would see is not only spinning up the ingress for Argo and for Airflow, but temporarily spinning up an ingress for Let's Encrypt so that it can validate that we own this domain name.
So while it's creating these resources, I have a question. So
Sure.
what if I already have an existing Kubernetes cluster?
In that case, we don't have a good story yet for migrating an existing cluster to CNDI.
So
But
I
I suppose
imagine if I work at a company and say, hey, like I go to our platform engineers and say, hey, like there is this cool tool, I can easily create Airflow like in 5 minutes. And then they would say, yeah, here's the cluster, EKS cluster we manage. And if you want to create, like it has to go to that cluster. Right? And then like one solution to that would be maybe taking these files that CNDI creates and somehow seeing like how to put them to the existing cluster, but that would be a lot of manual work, right?
Right, yeah. So if you were well organized with that original cluster and you had all of your YAML files separately, it would be kind of feasible to make that transition. Certainly most convenient right now for greenfield deployments where you can create a cluster that is isolated, that has kind of Airflow or Postgres, kind of one of these pre-built services that mostly works out of the box is where CNDI gets kind of shines the best. But we are thinking more about kind of API services and things people might be deploying that that are pre-existing.
But would you actually recommend to always have a separate Kubernetes cluster for these things? Like, for example, if I want to create like a Airflow cluster using CNDI, like would your recommendation be to always go with like standalone clusters so it doesn't interfere with like other things?
Yeah, I would recommend for a service like Airflow, running the cluster kind of isolated in its entirety is convenient, is easy to manage. It's kind of performant. It's not going to bump into the other services.
Okay, makes sense.
So we saw two ingresses come up there for a second. One was the TLS check from Let's Encrypt that passed really quickly. They just kind of validated, yes, you own this domain name, and the record was where it was supposed to be. And so now if we come to Argo, refresh the page, we have a UI that will show us kind of which resources are managed in Kubernetes currently. And so now I'm going to my .env file because I know that we generated a password to log into Argo. And again, this is something that we want Argo to know about, but we don't want it to be in our source code, and that's why it's in this file here. You can paste that into the password. We can see that there's kind of three folders here. You can think of the root application as the parent folder, and then two sub-applications that exist within that root application. The first one is Postgres, and we can see, again, a kind of a ton of resource created here. A deployment for Postgres, which relies on secrets and replica sets, a webhook service, kind of. And part of the benefit of CNDI is that all of these things can be generated for you correctly by the designers of the chart. And maybe I don't need to know exactly what this thing does. But of course, all of its YAML and associated resources are present here as well. Do the same at Airflow. We can see that there's been volumes created to hold our logs, secrets for communicating with Redis, and the web server continues to spin up. So all of these components are Kubernetes resources that we are creating on behalf of the user. And this is almost entirely driven by the Airflow Helm chart. So I don't need to be so much of an expert in how to deploy Airflow. Instead, we can rely on the Airflow team to generate the chart, and we can just leverage that chart downstream. So that's what we're doing here.
I have a question though about Argo. I did not use Argo. I don't really know like what's how good it is. But from what I understood, Argo and GitHub Actions are kind of the same thing, right? So they're both doing like this continuous, like the CI/CD stuff, right?
So GitHub Actions in the case of CNDI is persistent, kind of taking your infrastructure as code, your Terraform resources, and making that a reality. Argo, on the other hand, is going the other way. It's reading out from GitHub and saying, have these YAML files changed? And you can think of it kind of, it's polling that repo, looking at the cluster manifests, and every 100 seconds, it's calling kubectl apply with those manifests. So instead of us having to call kubectl and kubectl apply this YAML file, Argo is instead just watching the Git repo, pulling those down and applying them that way. And that kind of approach of the cluster pulling down its own manifests is called GitOps. And so Argo is a GitOps tool. It enables that workflow.
Okay. I don't think I fully understood this, but I guess here also one of the advantages that Argo gives you is this interface, which you do not have in case of GitHub Actions, right?
Right. Yeah. So Argo is talking to Git, but it's really just pulling down the contents of the Git repo and applying them. But yeah, as a benefit, because all of those resources are being managed automatically, you have a nice visualization of which ones have been applied and which ones are in progress. But under the hood, it's all just standard Kubernetes. The difference with GitOps is just that the tool is applying the manifest instead of the ops person. So with that, now all the Airflow resources have been created. The Postgres that backs Airflow has been created. So we can take it to airflow.cndi.link. And this time we didn't do anything fancy with the password, so it's admin, but we can log in. And we can see that it was even able to pull down the DAGs from my private repo without any of those credentials having been in source code. So we can enable the operator and trigger the DAG. And there we go. The DAG has run successfully, which proves that it was able to spin up the pod specifically for the workflow. The workflow succeeded and then stopped. So that's kind of how to get Airflow up and running in a few minutes. But of course, one of the cool parts now is that, thanks. One of the cool parts now is that you can modify the cluster after the fact. So if we find that Airflow needs more resources, somebody on my team could make a pull request to this file, run CNDI OW to render out all of the different manifests as well as the Terraform files that would be required to spin up an extra node. So all of the manifests and the infrastructure are now managed from this one Git repo. All it takes to change the cluster is just make a pull request to the main branch.
Okay. Yeah, awesome. And what's the main benefit of using CNDI compared to, let's say, hosted Airflow from AWS or some other, I don't know, astronomer? Is it price?
In the case of Astronomer, I would say price, yes. It's a similar service, and we would be really happy if we could look at their SLA and see how reliably and efficiently they can deliver a platform as a service. And if we could provide that level of quality to somebody self-hosting the service, I mean, that would be great for us. That would be a goal I'd be really happy with. Of course, Astronomer has existed for a while. They have built up, a great tool over there.
And they focus only on Airflow while you can deploy many things, right?
Right. And that's another thing to call out here is we talked just very briefly, you mentioned platform engineering. These are just the 5 templates that we've cooked up out of the box. One of the great parts about CNDI is you can create an internal developer platform where a platform engineer can create these templates for their team, all the way down to which interactive prompts am I going to show my team, and then kind of hide all of the complexity that isn't just those variables that they should be configuring.
See, but it's also mainly price, right? If I compare it, let's say, with hosted Airflow from AWS. And plus flexibility, probably, because I heard that I never used this hosted Airflow. I guess it's not super flexible.
Yeah, I think you have a lot more knobs to turn if you're using CNDI. You can configure everything about what kind of VM should this run on, how many nodes, how many nodes should make up the cluster.
Yeah.
It's all way more configurable than kind of relying on the common denominator of the cloud.
Okay, and how many people are working on CNDI?
So there's 6 team members and 4 developers kind of actively pushing code.
Also, for developers, you mean that are not part of? Because I guess you have like a company behind CNDI, right? And then
Yeah.
there are some developers who are not a part of the company, who are more like active contributors from outside.
No, they're all internal contributors. It's just two of them aren't contributing code. Some are contributing kind of the website, for example.
I understand. And are you open for external contributions?
Yeah, we are.
And
One of the questions
yeah.
one of the questions I read in the prep doc
Yeah.
was the best way to contribute.
Yeah,
So like
exactly.
right.
That's what I was going to ask. If somebody
Sorry.
wants to contribute, how do they go about that? Yeah.
Yeah. So the best way right now would be to try the tool, and if there's any feedback you could provide around how to make the tool better. We do have an open roadmap that users can check out over here on the CNDI repo and then in the project section. And this is kind of where everything is managed. But I think, the best way would be either to open an issue or open a discussion if you think of any way the tool could be improved. And then we'll kind of work to get that triaged and implemented.
Okay. And what do you want to have next on CNDI? What kind of tool you want to enable others to host, to self-host?
Yeah, there's a couple. Kafka and Spark are two that are kind of in progress right now. Of course, really complicated tools, so the templates take a lot of work to put together.
Like Zookeeper and all this stuff, right?
Yeah, yeah. We have to learn what all those words mean.
Okay. Have fun.
Thanks. Yeah.
Well, so we will not have to learn it ourselves, right? Because you'll do all this work.
Exactly. And platform engineers can then, another thing we're working on is kind of more expressive and flexible templates, so that even if we don't solve it the first time, the smart ops people in your organization can create templates for their team. But yeah, hopefully we can get Kafka and Spark off to a good jumpstart in the way Airflow kind of accelerates the process.
Mm-hmm. What if I want to request something like, let's say, Elasticsearch, or it's the like I think there's an alternative, the correct name. So what if I want to request like this open source alternative, free alternative, open alternative of, I think it's open source, right? Anyways, if there is a tool I want to request, like how do I go about that?
Yeah, so if you go to the same spot, it would be the CNDI repo, and then projects. I don't like how this is just project 6, but that's a GitHub thing. So yeah, the CNDI repo and then projects. We have templates and deployment targets. So if it's Elasticsearch, you would go to the template section and you would actually find probably that Elasticsearch is already there, which means it's one we're kind of aware of. And this is a long list. So we're also...
I see. So probably you can go and vote, right?
Pardon me?
You can go and vote, say, okay, like, please, like, what's the status of Elasticsearch? I need it, please.
Exactly.
I see.
More mature repos would have, don't leave a comment, hit the upvote. At this point, leave as many comments as you want. We're happy to take them. We'll do that for as long as we can. And then kind of along the same lines is deployment targets. So, maybe you don't want to deploy to EKS or EC2. We want to be able to support deploying to DigitalOcean or vSphere. So if people have recommendations for targets of where to deploy clusters, there's a spot for that as well.
Okay. And when it comes to Elasticsearch, I guess the license allows you to self-host it, right?
Yes. So licenses are quite a discussion
Difficult, right?
in the last couple months. Yeah. We are making templates for all of the community editions of these applications. And if people wanted, we could also make it even easier to deploy the enterprise versions of these solutions as well. But for now, the focus is on templates where the license situation is pretty simple. But yeah, for Elasticsearch in particular, I haven't looked at their license lately, but I imagine they have a community version that's fair enough to deal with.
Okay. So do you have any advice to anyone who is watching this?
As it relates to the tool, I think kind of the best way to get a handle on it is to give it a try. In general, I think if people have time to contribute to open source, that make a tool that's useful to you and see how far you can take it. It's fun building these tools, especially when you kind of can have rewarding conversations with other people and see some benefit.
Indeed. And I think right now Hacktoberfest is happening. So if somebody wants to contribute to open source, I think that's a good chance to do this.
Yeah, absolutely. Should be a fun month.
Yeah. Okay, Matt, thank you for coming today and doing a demo, showing to me. So you've done amazing work. And by the way, one thing you did not show is how to give you a star. So maybe before we wrap up, you can do that.
Yeah, we're at 64. So take a look when you watch this video and see how far we've come from there.
Yeah, so this project definitely needs more stars. So please go ahead and increment this number. And with that, I think that's all. Thanks a lot, Matt.
Thank you so much for having me. That was awesome.